Hello, everyone. That sounded very grim. It might be. I might be walking straight into my own... I don't know. I don't know what to call it. But... multithreading. It's happening. Into my own execution. But where I'm also the one doing it. But not in that way. I guess we'll see. Hello everyone. Very exciting title. I guess we'll see. I've copied your idea and making your own OS. You cannot do that. I copyrighted it. I'm the only person allowed to make operating systems. Actually, because of me, Windows is no more. Linux, gone. Mac, I let them stay. They just have to pay me a lot of money. Obviously not. You're more than welcome to do that. Alright. It is less hot than it has been. It's not. I guess it is summer after all, so we have decent temperatures in Spain. And, yeah, I was even able to be outside for a bit. It was fine. It's like a... It's nice when they turn off the oven, I guess. Very enjoyable. Still got a double fan setup. 2 fans blasting from each direction. Neither of them feels like it's doing its job. Not gonna lie. Genuinely, this fan here on my left is not doing anything. You are gaslighting me. You are I don't believe you're actually doing anything. That's ridiculous. Anyway. Multithreading. I guess it is time. I mean, I've thought about how to implement it, and it shouldn't be too difficult, but I guess we'll see. Alright, here's the deal. Pretty much everything nowadays is multi-threaded. I think it would be weird if something was... Well, unless you explicitly built an application from, like, straight up from int main. And you didn't explicitly do multi-threading. But, for example, something very, very common. You're making an app that talks to a server, an API of some sort. Just to talk to the server and be like, hey, give me this. And then the server gives you the thing that you asked for. Thanks to the beauty that is TCP, will require like a dozen packets back and forth between, you know, going from your application to the networking stack on your operating system, to the router, to through the entire internet, to the server, and then back to you. That can take a little bit. It can occasionally take a little bit more than 2 milliseconds. And then, you know, nowadays we do a lot of extra BS. Just hook up a debugger or like network traffic analyzer to your phone, to any app, to your computer, and look at that. The amount of network requests that are happening. If every application that is making those network requests was, you know, single-threaded, it would have to wait for the request to be fulfilled. And you would be able to do nothing. Your entire computer, your entire everything would always freeze. So we do multi-threading. Usually the way that it's done is something like, I don't know. Usually there's libraries that handle it for you. So even if, maybe if you're a beginner, you don't even notice that this is happening. But you got something like, I don't know, make URL request, and then something like that. And then you can have a little closure, lambda, function pointer, some sort of place where after it's done doing the request and the data is there, you can, actually handle it. That is done with threads. Usually a function like this will probably work in a background thread. It's going to use that background thread to make the network request. That thread is going to be stopped until it receives a response, at which point it is going to handle this part for you. And even then, for example, let's say that the request that you're making is like to get some image. And so the data is image data that you then need to show on the screen. So you need to do something like updating the UI. The UI is running on the main thread. This is running on the background thread. Usually you won't be allowed to update the UI from the background thread. So you will need some sort of like way of synchronizing these two things. Going back to the main thread to execute this thing here. So not networking, multi-threading is not exactly the most straightforward thing. Another thing that can happen a lot, let's say that I have, I don't know, I'm counting the number of lines in all my files. I actually have a program that does that, but it's not multi-threaded. Really doesn't need to be. 60,000 lines, by the way. Dangerously close to 67 and 69,000, but whatever, 67 is dead. Who cares? Mostly. Anyway, so I have something like this that does that count. Counts the lines of file A, file B, and file C. And it's going to update this number. That's the one that gives me that, or even, runs here. The way that this function is implemented is like, it's too hot to think in here. Something like this, then, go through each of the files. And for some reason, this runs each of these in a background thread. So it's like count file, and then the file that you passed it. And let's say that also has the count, so it updates it. And, count file just works like this. Not sure why you would implement it like this. The entire example is kind of falling apart, but it doesn't matter. This one takes, of course, the file and the count. None of this is any particular programming language, but it doesn't really matter. For some reason, it decides to do this. Actually, can I just put the count out here? It makes a lot more sense for me to do it like that. Alright, so let's just say that this is how it works. Can I at least use C syntax highlighting? Because it's all white text. It's kind of weird. Anyway, yeah, it reads the value of count. It then modifies it, and then it writes it back. When you're doing multi-threading like this, you are bound to run into issues. Because, the first one, A, reads the value, it's 0. Reads the number of lines in A, that's 5 lines. Writes it back, that's 5. Then B and C, these two, at the same time, read the value, that's 5. Each of them has 7 and 8 lines. So they update that. This one has 12, this one has 13. They write it back. Only one of those values is going to be reflected. Right, so you need to have some way of telling it, like, while count not available, just wait. Which will essentially kind of synchronize them. There's a whole lot of logic and a whole lot of ways of handling this type of situation. For making sure that a specific resource that is considered sensitive can only be accessed by one thread at a time. But essentially, with something very visually simple like this, it should be easy to understand. You know, we have 3 files. First one, I'm gonna read the I'm gonna be working with this value, so you guys cannot access it. So these two have to wait. All right, get the value, count, write it back. Then these two are like, okay, I'm gonna read it now. Only one of them is gonna be given the value. So this one has to wait. This one has to wait. This one does it, reads the thing. All right, it was 5, added 7 lines, that's 12, writes it back. Now this one is finally able to read it, reads 12, it has 8 lines, now has 20. And now we were able to count the number of lines using multiple threads properly thanks to doing a little bit of synchronization. Right, so even threading is a non-straightforward topic. Wait. Does the ARM CPU have a timer that can fire interrupts? It does. Use the BCM system timer for sleep functions and then use a generic timer on each core to get interrupts for scheduling. Yeah, that's kind of what I do. We will have to look at scheduling code in a bit, so you can see what I'm doing. All right, before reading the rest. So there's kind of 2 things that you need to consider. Even if you have multiple threads, there's 2 things that you need to consider, which is synchronization between threads, you know, being like, okay, move from this thread to that thread, do this in this thread, do this in that thread. And the other thing is like, there's this resource that needs to be accessed by multiple threads. We need to make sure that only one of them can access it at a time. If they're writing to that resource. If they're reading from it, maybe we can allow them to read from the same time. It's on a case-per-case basis, but yeah, kind of like that. Luckily, the way that I am... the reason I'm doing multi-threading should not require me to deal with these things too much, but I have to keep them in mind. Alright. Essentially, the reason that I want multi-threading is not so that you, as the application developer, can just spawn a background thread for your application, necessarily. More so, it's so that I can provide certain things that are currently available in kernel space, but not in user space, and it's leading to some really awkward code in the kernel folder of the operating system. Namely, the clipboard, the terminal history, and an LSP, or LFSP, because it's run on the file system. So it's a language file system protocol. These things should not be in the kernel. It makes no sense that they're in the kernel. Well, it makes sense because there's this limitation that they cannot be in user space. But they shouldn't be in the kernel. If the clipboard crashes, if the LSP has an error, notice over there, if the LSP has an error, will that crash the entire system? To be fair, the LSP is literally not even an LSP, it's just a skeleton of what that would look like. But, you know, if I develop it further and it crashes, that's gonna be a problem. So, the reason that, I think if I show it with the clipboard, it's going to be easier. The reason that these are in the kernel is that in order to have one of these system modules for the file system that expand the file system, I want this to happen in user space, but the reason that I have it there is that in order to do anything with this file system, you use one of these system modules, and it has all of these function pointers and a few others that aren't used here, but are also available. And all of these, if they were in user space, would kind of act like different entry points to your program. Essentially, let's say that we have a program that actually runs the clipboard, which we should. Let's say that it has its own like little main function. Not sure why I've been skipping this, right? And it can load the module, the clipboard mode, clipboard mode, Right, you can load this module, which makes it available in the file system. Now other applications can see /clipboard. They can write to it to copy. They can read from it to paste. Cool. The problem is this application is then going to be, I don't know, what can you, let's say that it shows the visual clipboard, right? It shows you a little history of the clipboard so the user can actually see it. So that's going to require updating UI as well as reading input. And let's say that actually that is triggerable through a shortcut, right? So maybe not even, actually, let's not say that part because that's just going to defeat my point. But anyway, let's say that our application is running, right? It's running this thing, and then it goes down here, and it runs this thing. It gets to this point, and now someone else is actually accessing the clipboard. When my program is currently executing here, it now needs to execute here. That is going to probably mess up the state of the program. When we return here, it's not going to be super valid, and it's probably going to crash. Now, there is a chance that we can do it cleanly, but that's not the correct way to do it. The correct way to do it is that each of these functions, whenever we need to call it, we give it its own little environment to run into. Its own stack, its own program counter, its own access to the CPU, completely separate from the main application. A thread, essentially, because that's at the end of the day what a thread is. Now all of this has to do with like virtual threads, so like everything's still going to be running on one core of the CPU. At a minimum, the CPUs that I support have 4 cores. At a maximum, they have 4 cores. There's not a whole lot of variety. But yeah, I'm still gonna be using only one. Because yeah, the plan is to like isolate stack, program counter, and registers from the concept of a process, so that then you can spawn multiple threads, and then we'll need to handle, like I said, synchronization, like do this in another thread, spawning threads and all that stuff. Spawning threads isn't going to be necessary for this. It's like that's going to be handled by the kernel. It is going to be creating the threads, not the application itself, although it could also do that. But yeah, for the sake of the way that the file system is structured, it doesn't really need to do that. But yeah, essentially, these act as their own entry point into the application, so they need to be their own completely isolated entry point into the application. Well, completely isolated, not really, because most likely they will need to share some resources. But we should be able to get away with the first version just doing threading, then worrying about synchronizing the threads, worrying about you know, critical sections, semaphores, mutexes, whatever you want to do for that stuff. It's going to be a lot of that. So it's going to be a long thing. But yeah, we'll see. Essentially, I will need all of that stuff. I will need full multi-threading. First, on one core. Essentially just running different threads of the program. That's it. But within the same core. They will still run sequentially. That's the good thing about it. Which means for debugging, I will get a sequential sequence of what's going on. Sequential sequence. I will get a single sequence of what's going on. That should make debugging easier. Working with actual multiple cores is going to lead to needing more stuff. So that's also not a thing that I need right now, but I will eventually. Although that one will give us actual performance boosts, this may actually do the opposite. Because it's now more things sharing the same CPU. Alright, so that's the plan for today. Reminds me I gotta fix or rewrite my allocator to actually be multi-threading aware. That's another one. That's another one. Yep. Yeah, I'll need to handle that. Do mutexes require a syscall? Don't think so. Should multithreading be handled? I believe it's usually handled in user space. Like again, the code that I wrote before, right, with the count. This thing. I can literally just have a... Yeah, actually, it does. Never mind. Okay, no, because... Probably does. Probably does. Now that I think about it. I started off saying it doesn't need it, but I think it does need it. But it really depends, I guess. But yeah, if I have this count line, right, which is just going to do code like this. While count is not available, you're just going to idle. Let's even write it like that. Then, gonna do this, and then count plus equal lines of file. Right, so this should ensure that my thread is going to wait until a resource becomes available. Oh, and by the way, maybe let's release the resource back. Otherwise, yeah, not gonna work. And yeah, by default, true. Right, so the first thread that gets this, the first one of them that gets this, is going to see this and be like, okay, it is actually available, this won't run, I'm here now, I'm marking it as unavailable, and I'm going to run my code. Then I'm gonna mark it as available. The problem is, maybe I got to this point, my thread got interrupted, another thread started executing, also got to this point, also says, oh wait, it's available now, I can use this resource. Marks it as unavailable, does this, marks it as available again. So they both think that they have exclusive access to this resource when in reality they don't. So to fix that, probably the best way is to make sure that, you know, instead of having something like this, we have an acquire. Acquire. Which is a syscall. When this runs, the kernel, which has a lot more control over knowing which threads are executing and whatnot, will handle that same logic that was here a second ago, but it's going to make sure that only one thread has access to it. It's going to be like, is the resource available? No, then wait. Is the resource available? Yes. Then here, now you have it, and I'm going to make it unavailable for anyone else. So, yeah, I'm thinking the kernel probably has more control over who can access that resource. So that means it's probably better for the kernel to handle these types of things. Can it be done in user space? I don't know. I guess we'll find out. For that matter, that was like more so of a... Again, there's a whole lot of concepts of how this is handled. Mutual exclusion is mutex. Each thread cooperates by acquiring the lock before accessing the corresponding resource. Some systems implement... Okay, semaphore is kind of the one that I just did. There's a lot more complex ones as well. What is today's featured article? Donkey Kong! Okay. I was just looking at the guy here. The semaphore is, if I'm not mistaken, the thing that I just showed there. But again, if I had to implement it, which I will, I would do it in a syscall. Again, mostly to ensure that I truly do have access to that resource. The kernel can make sure, because it knows which other threads are running. My thread cannot, because it doesn't know about the other threads. Now, the funny thing is when the kernel, this is why I'm not doing actual multi-threading with multiple cores at the same time that I'm doing multi-threading in user space, because the kernel still runs sequentially. Everything runs sequentially. Everything that I'm going to be doing is like fake, well, technically, what we already have as concurrency, multiple processes running at the same time, seemingly running at the same time, aren't really running at the same time. They're just running one right after the other very, very quickly. Which means the kernel sees them running sequentially, and so it's very easy for it to do the kind of thing that I just said, and to kind of organize everything. But if on top of that we have physical threads, actual completely separate CPU cores, in other words, completely separate CPUs, with their own registers, their own cache, even their own things going on, truly running in parallel at the exact same time, not faking sequentially, but actually running at the exact same time, that would make it a lot more complicated. So, yeah, the kernel can handle that, but if on top of that I start working with multiple cores, it's gonna make it just give up, just give up, just give up. We're just giving up. Which OS KDE you are using as a main? I'm using Debian. Unfortunately, Hannah Montana OS is not compatible with my system, so I'm stuck with Debian. How to start programming? I'm not exactly the best person to give you advice on that, to be honest, but trying something small in a relatively simple language and then seeing what you like, and just, I think the best way is essentially by writing code, which you'll have to do. That's kind of how I learned. I was just like, alright, let me get some water, hold on. I was just like, hold on, how do I do this? Oh, I gotta pick a programming language. Well, how about this one? Okay, how do I do this thing in this language? And that's pretty much what I did. Same as today. Do I have any idea what I'm doing about multithreading? No fucking clue. Zero. But we're gonna see what's up. That's essentially the plan. Alright. They're called mutex locks, so I'm pretty sure I'm gonna have to be mute while I'm implementing them. But I'm not implementing them right now, so let's yap. Alright, off the top of my head, actually that's a very neat representation of exactly what I needed. I forgot I added these comments here. Essentially, already, like I said, there's multiple processes running completely independent from each other. They don't share any resources. Completely independent from each other sequentially, but that means that the CPU needs to interrupt one of them, store its state entirely, then take another one, take its state, put it in the CPU, execute that, come back, go to the third process, and so on. Right, so the CPU has registers, 31 registers plus a stack, pointer, program counter, and this here, which is just a status register, well, system register really, which indicates So it really has more registers than 31. You know, it has 31 that are relevant to the process, stack pointer, program counter, and the SPSR or SPSR, which controls things like which interrupts the CPU can receive during that time, and if it's running in kernel mode or userland. Very important. If an application manages to change a little 0 to a 1, it's suddenly running in kernel mode. Becomes privileged. So, yeah. Essentially, this is all the information that we save in order to give the CPU to a process. There's a bunch of other stuff like the process ID, whether the process is sleeping, whether it's suspended, when it's supposed to wake up if it's sleeping, whether it's ready to run. This will probably need some modification. But yeah, all of that stuff. Where the stack is located, separate from the stack pointer, where the actual stack is located, also will probably need some modification. As well as file system stuff that it has, allocations that it has done, a graphics context that it owns, input buffer, other input buffer, networking buffer, scrolling buffer, because scrolling needs to be handled in a special way, signals. This one's probably going to go away once we have threading, because the other thing, did I mention it? The other thing besides file system that I really need threading for is signals. Signal handling. Right now, there's signal handlers that are only available in kernel space, because user space cannot provide, again, a separate entry point from its main one for the kernel to handle things. Right, so all of this information the process probably doesn't need right now. What is your goddamn problem? That's C++ complaining. No, it's not. It's C11. Okay, I read that wrong. Sorry. I will not apologize to C++, actually. I was gonna say sorry C++, but no the fuck I'm not. SP is stack pointer, yes. MPC is program counter. Also, 1 year, 1 month ago. 1 year, 1 month ago, and I think I saw it 1 year, 2 months ago. The project is officially over a year old. Anyway, so the scheduling code will need to change quite a lot, which I'm not very happy about. But really, all we need for the thread is this stuff. The problem is, well, I don't necessarily need to change the scheduling code right now. Kind of, though. No. The thing is, signal handling and file system handling, that's not threads that you're going to run like a background thread. Like, okay, I need to do some work in the background, I'm going to spawn a thread and do it there. This is, again, very specific behavior that the kernel knows about. And it knows how to handle. So I don't need to handle scheduling just yet. Hopefully. Again, I can try to implement this as progressively as possible. I should have a fork syscall. Isn't fork in Unix literally copy the current process and then it evolves separately? Isn't that just the most ridiculous thing ever? It is the most ridiculous thing ever, by the way. I believe that's how it works, but Unix is ridiculous. What can I say? Why Why? At which point did that make sense? Especially when you think about, like, back in the day, they had a lot fewer resources. This sounds like something an Electron programmer would do, not a Unix programmer. You know, this does not sound very limited memory of them, very limited processing of them. So I don't know about that. Anyway, hi Peter, how's it going? All right, so am I safe moving these around? I think so, because the thing is, again, I need certain things to become thread specific. So the plan is to introduce a typedef struct thread that is going to contain this stuff, and then the process has a main thread, because by default it will have a main thread. It makes no sense for it not to have a main thread. Even if I decide to do things like this, technically, in and of itself, the clipboard does not need to have an application that runs. If that's the case, then just don't give it a process, give it a thread. Just give it this structure, instead of giving it all of this stuff that it doesn't actually need. So yeah, I think we're okay with having the process have a main thread. And again, I don't actually have to worry about scheduling threads to run, because I'm only going to be running them in specific cases. So we're good. So we're good. We don't need to do that yet. I am already dreading doing this because I'm realizing how many moving parts I'm going to have to move. Steam, I was trying to quietly close you. You weren't supposed to do that. Right, so hold on. About fork. Now, I want to see how to use fork in Linux. Fuck right off. It creates a child process by calling the fork call. After child process creation, both parent and child process execute the next instruction. The child process uses the same program counter, same CPU registers, and same open files which use in the parent process. What is the point of that? And how do you usually handle it after that? Do you have the finished code so I can go through it? Here. Alright, so this is the code that's going to execute for both of them. Child process ID, by the way, uninitialized. Great, start. Doesn't really matter because you could just do equal fork. Alright, so that will create a new process and give us a new process ID. If the process ID is less than 0, then it failed. We'll return. If it's 0, then oh my god. Oh my god. Again, this is a syscall, right? After the syscall, both programs will run this, both the parent and the child. If this value is less than 0, then fork failed. Both of them, well, not both of them will exit because the child failed. So the child will never get to run this stuff. Poor thing. But if the child ID is 0, then we're in the child process because it never ran fork, so it kept the value of 0. Except it never kept the value of 0 because this is actually uninitialized. It could be 0. It doesn't necessarily have to be 0. So there's a chance this code has a bug. At least looking at it, first glance, feels like that. You know what else? It also feels like my monitor is a little bit dark. Fork probably returns 0, but fork won't be executed. According to what it's set up there, the next instruction will be executed by both, but not the current one. So fork will not return anything. The child process starts its execution here. This is the first instruction it's going to run. I think. I'm not sure. We could try to run this, but I can't be bothered. Anyway, yeah, if it's 0, assuming that the code is correct, that I'm either missing something or, we just put a 0 at the beginning to explicitly initialize it to a 0, then since the child process never ran fork, its value will be 0. That's how you know that you're in the child process. Otherwise, this one did run fork, which means it has a child process. It is currently the parent process. It runs this stuff. And then if the wife exited, WIF exited. So you just wait for the child to finish. And then you print that the child finished. Interesting way of doing things. The question that I have is, what if the code that I want to spawn is not my own code at all? What if I want to... Well, I can do system, right? Is system internally calling fork to create a new process? Then replacing it entirely with my new process? That was more so the question that I was trying to ask. Is you have to do a fork and then load up another process in the child. Okay, so the child will be wearing the parent's carcass, essentially. Did I have to make it as unpleasant? No. But where's the fun in not doing that? Absolutely horrifying. Why? Why? What was so hard about just creating a new process? Whatever, man. Whatever. Anyway. Okay. Right now, all I've done is move all of this stuff out. But that means we're going to get a fair amount of issues in the code simply because I moved this code out. Which would require... You know what I'm going to do? I'm going to do something else. I'm not going to move the code out. First off, I'm just going to keep it here. I'm going to mark it like that, and I'm going to copy it over. Alright, so I'm technically going to have this stuff repeated in 2 different places. Because otherwise I'm going to have to change a lot of code just to append the main thread at the end of like probably a few dozen of these things. I don't want to do that. So probably the easiest thing is for me to just duplicate it for the time being. After the stream, when I feel like torturing myself a little bit, I'm gonna do it properly. Alright. Before that though, I did move this, and sometimes moving code because of alignment could cause crashes, so I just want to make sure that everything works. Is there anything that I updated in the meantime? I technically moved the terminal code. This thing is running in its own little graphical context. But yeah, there's not a whole lot to show. That will never work. It's still a little buggy. I just saw a couple bugs in there, but whatever. This thing needs to be able to scroll as well, which it currently doesn't, but whatever. I just want to make sure that everything continues working, because again, alignment can be a little bit of an issue. It was for these, which is why I have to make sure that they're always aligned. explicitly, but yeah, never hurts to check. Unix compatibility layer for the fork syscall if you ever wanted one. I would never want one. Why would I want that? That sounds... Nah, let's not do that. Okay, so yeah, we have this information for a new thread. And we're going to set up in our demo program. Hold on, first I need to check, do I have any syscalls that I can use to test this? I believe for signals I created a syscall that is probably not implemented, but I need to check. Handle signal using a signal handler. Is this implemented here? Yes, it is. And the kernel will then probably print an error if you use this one. Yep. Okay. All right. So right now, if you try to implement a signal handler in your application, it will tell you that syscall handlers, signal handlers, are not supported in user space yet. And it will simply return a 0, meaning, whoops, sorry. But, well, we're going to make it actually handle it. And again, the whole idea is you can't schedule your own threads yet. We schedule them in a control environment. That way we start building this whole thing up kind of slowly. Now I'm going to do this in the demo program. We're going to do a handle signal. Which signal do we want to handle? Well, I guess what matters is which signals are being sent. Quit. Quit is a good one. Okay, so signal types. Can you... Clang! It's not working. God damn it, Clang. Clang is not working again. So I have to write my code manually without autocomplete. Imagine if I also used like Claude on top of that. Alright, and the signal handler looks like this. Wait. I already have one. I remember I started implementing this and then I was like, oh no, it's more complex than that. I need a signal handler. What is that thing doing, bro? To be a dog. Anyway. We already have a signal handler. It's just gonna print, I'm told to quit. And then it's going to update the should quit thing, which is not used anywhere. But we're gonna, again, do it progressively. This is updating a value. That's where I believe we can get away actually without putting a lock on this thing, because there's only one way that this function gets called. It's not gonna get called by multiple threads. It can only be called by one thread. It can only be modified in a single place, and the other place is just reading it. But yeah, well, we'll see if it crashes. The point is, I'm expecting to see this print by the end of the day. If I try to run the application right now, I will get the error. When typing out functions and using it, we'll get the entire function definition typed out. Yeah, it does that. For, actually, the demo program is the middle one. That's very convenient. For function pointers, it's really annoying. All right, and there it is. Signal handlers are not supported in user space yet. There's our error. By the way, this program now has a little menu to show different demos, although what matters in them is the code. So, like most of them, you won't see anything happen on screen. The code of them is what's important. It's supposed to be demo code, not a demo application. Well, it shows an image on the screen. That's very important demo, because it's a picture of that guy over there. I know he looks like an Iberian ham, but that's a dog. Okay. For this and file system modules, we'll need to set up an isolated environment, thread-like, for them to run in. So, I actually considered calling the stream threading and not multi-threading, because again, we're not scheduling these threads, but it's the same logic. It's just that scheduling the threads will require a significant rewrite of the scheduler, which I don't feel like doing. Not on stream, definitely, because it's just copying code, adding a property in between this and that. That's a pain in the ass. Nobody wants to do that. I think he's mostly handling the heat well. It's just dramatic. He wasn't handling the heat well. There's a fan that actually could reach him if he tried. But he's doing okay. Alright, if I enable this thing, this is the syscall for actually creating the signal handler, gets the type, gets the handler. The handler is going to be in user space, I believe. And then it will not do anything, really. I don't believe this is actually going to do anything. The handler is in user space, yes. This is a user space of value, so we're good with that. Essentially, we're just going to create a thread. Although I'm going to move this code, I'm just writing it here for some reason. It makes no sense for it to be here. Where the program counter is going to be that entry point, the handler. The stack pointer, we're going to need to create a new stack for it. The SPSR, again, is configuration for the process, including whether it runs in privileged or unprivileged mode. We're actually going to copy the one from the process. Stack size, stack physical address are going to stay the same. Registers are going to be set to empty for now, but in reality they're going to be filled in by this thing when the function gets called. Right. And then, to register a signal handler, this will require a little bit of a rewrite. Does it need a rewrite, or do I just want to do a rewrite? It doesn't technically need a rewrite, but it's better to have a rewrite, because again, signals should always be handled as a completely separate thing from the program. Right now, they only work in kernel space, because in kernel space, I can just call the handler directly. Whereas if I try to do that in let me try, actually. I do believe these processes can send signals, but they cannot receive signals. I'm going to hard code its process ID. There is a way to get it, but I don't remember what it is. Anyway, you're going to send a sig quit to process ID 7. You're going to do that immediately after handling this, creating the handler. If I try to do that, that's going to crash the entire system. Because the signal handler is running from kernel space, and it's actually in user space, so there's logic to prevent that from happening. Of course, that crashes. All right, that's why we want to do this. So signal handlers should always be handled as a completely separate thread, never as just a function. All right, there is an add starting and some boilerplate to be written. So I'm gonna be running the add while I write the boilerplate. All right, essentially this whole thing is gonna move over. It's going to register the signal handler. The thread should probably also know. Hold on, yeah. Let me create the thread from outside of here. Or even better, give the thread knowledge of which process it runs in, because that's kind of important. Then it is going to... I'm going to create a new function, which is going to be... new thread. For a process. And this function is just going to do that little bit of boilerplate that I just wrote. I need to I need to do a severe refactor of this class. I need to move all of the stuff which is part of the file system of procfs out of here. I also need to like clean it up because I've added a lot of stuff specifically for this, which it doesn't use yet. But since I'm going to be rewriting a large part of it, doesn't really matter right now. You're going to return a new thread, where again, it's program counter. Oh, hold on, I forgot that. An entry point. It is going to have an entry point. The entry point will be this. Then the process ID is going to be, taken from here. Isn't it nice to be able to write this stuff without caring about the order in which you're setting these properties? Like that other language, the one with the plus plus, that's actually a minus minus, handles it. That and that I'm going to handle in a minute. And also registers I'm already doing. SPSR I'm going to copy from the process. Okay. Why didn't I just copy the boilerplate that I had here over here? I have no idea, but whatever. Alright, so this is going to be creating a new process for this, a new thread for this process, not another process for this thread. So we're going to be creating a new thread for this process, as that is going to help us do this entire thing. Now, for setting up the stack, I don't think there's actually like a single place where I'm doing that. That kind of sucks, because there's two ways of starting a process. That's done by either the kernel or user space process, and it's a little weird. Is this not being set anywhere? Why is stack fizz being set to 0? What is this even? Is this being used? I think this is... I think this is misleading. The name of it is misleading, I think. No. What is happening with this property? Here I'm setting it to 0. That's just me. Here, this is the reset function, I'm pretty sure. This is the reset function, so it's actually just resetting it. This is the definition of that. This is the definition of that in the thread. Here it's being set to 0. And here it's being used exclusively to subtract something from it, which is going to give us a negative number. Okay, so it is being used. It's just set to 0, but I think it's this is the stack of the process. This one here. This is the physical stack of the process, where it actually sits in the kernel. Except it's not physical because this part of the address is virtual, but whatever. This is where it sits according to the kernel. This is where it sits according to itself. This fizz value, though, who's setting that? This value is not being used. Like, at all. Which then makes me wonder what that other thing was about in the elf file. Well, that's one property that we don't have to care about. But what is this, though? Because that's confusing as hell. I'm reluctant to take it out. So if I take it out, it looks like it wants to crash everything. So I'm a little bit, reluctant to do that. Hello, Dulce. Okay, well, I don't know if this property is needed for anything. I'm just gonna get rid of it in the threading. Doesn't look like I need it. So all I really need to do is set up a stack for this thing. And that is actually being handled by this. But again, it's being handled, now this is actually what I wanted. It's being handled by two different functions. This one, which is for kernel processes, and this one, which does it differently, to be fair. Okay. And once again, virtual memory comes in to fuck it all up. Because virtual memory, you're going to have to explain to me what the point of view is, number one. And number two, how do I set up the stack in a nice, neat little place? This is so annoying. This is so annoying. Anyway, yeah, it's being set up here. The problem is the stack is where is it mapped? I'm getting so confused here. Where is it getting these values? The stack is set from base here That's where you set the stack. Okay, this is copying arguments into the stack, which is where argc, argv sit. Well, argv sits there. Argc is just a variable, so it just sits in a register. But the value of stack here is just p allocation. Okay, so actually, never mind. The issue that I was gonna have, I don't really have, which is that the stack is always in the same place in memory. That's not actually true. Except it is. This is for kernel processes. Okay. I'm reading the wrong one. Like I said, it's hot as fucking here. It's so hard to think. Loading, process loader. Alright, the stack starts at stack top. Stack top is being set at a hard-coded address. Okay, there it is. There it is. Yo, what's up, Divine? Hello. Hello, Zero Duckies. We're doing we're doing threading. Multi, bit of a strong word, but technically true. Also, calling it just threading sounds weird, but yeah. Okay, so the stack for the process sits in a very specific place. A hard-coded place. This is why I hate working with virtual memory. Do you realize how easy it would be for me to set up a new stack if I wasn't working with virtual memory? Just be like, hey, here's some memory. Take it. This is your stack. But now I have to be like, wait, hold on. You want a new stack, but hold on. Your stack is now going to be sitting at this address in memory. I have to give you another address in memory. But how do I get that address? Wait, now I have to hold an entire different logic of how to do that properly with virtual addressing separate from physical addressing. This is genuinely so stupid. I don't like virtual memory. I don't get the point of virtual memory. And yet, without virtual memory, ELF processes tend to break very, very easily. And I really hate that. Do you, like, that is really disappointing is how much complexity is being added by virtual memory to this fucking system. It's making everything so annoying. So annoying. Rand, that's the funniest part is nowadays actually a security feature is to randomize that memory. I'm gonna have to take a look. I'm gonna want to simplify the virtual memory code a lot, but what can I currently do to fix this, to make this like properly? I mean, I could just say, okay, your next thread's memory is gonna sit here after the rest of the memory, right? It starts here, ends here. Alright, so after that is going to be the next stack. But I have to keep track of that. So that sits at the stack pointer, because stack pointer is actually on top at the beginning. User process allocated at entry stack with these physical addresses, which is 0, 0, by the way. That's, again, the physical address is not being used, so I think I can get rid of that. But anyway, entry point is PC. Memory mapping stack limit is the top of the memory. No, is the bottom of the memory. Stack top is the current top of the memory. So for me to give you more memory, I need to allocate it at this location. To make a new stack for the process, I need to use that. Alright, so to give you a new stack, its limit is going to be located. It's going to be located here. Its top is going to be located at proc stack top plus proc stack size. To be fair, that makes it easy. The stack is this one. The stack size is this one. Am I okay with modifying this value though? Actually, what I meant to do was this. But am I okay with modifying this value? See how many things I have to consider. That is really annoying. Stack fizz, yeah, you don't have that anymore. I set it in the wrong place. Alright, and stack limit is not really used. A little bit weird. Alright, so is the stack top, who's using the stack top? This is kernel stuff, not important. The stack can be grown, but that's not the same as setting up a completely new stack. It sucks that I didn't write most of this code either. Like, I wrote the original version, then it got refactored, and now it's so hard to keep track of what's going on. Stack top, stack limit. There is again with the elf file. I don't know what the fuck you're doing. Here for creating a new thread and for drawing memory. Okay. So I think technically what I'm doing here is not super right, but it is okay. Which is essentially that your process has this stack right now. All of this is allowed to be the stack. Your process can use any of this with no problem. Then, if it tries to use anything here, the stack will actually grow. And it will handle that with a page fault handler. The problem is that I'm trying to put the new stack somewhere, and where the fuck do I do that? Here. So if I literally just say, hey, the stack is gonna go here, it can handle that, no problem. But that isn't really good enough. So I don't know what to do. Because technically then the main process can grow its stack so much that it overwrites the stack of this thread, and that's not okay either. But What if I, instead of that, I do this? I just set a new stack. I think that's the only thing that I can possibly do. So in the process, I'm going to keep track of how many threads it has. I'm going to give it a new stack function as well. Which is going to handle this. And then in the original code where I handle this, I'm actually so lost. I hate all of this code. I hate all of it. I genuinely hate all of this code. Virtual memory is making process handling so complex for no real benefit other than making the memory look neat. It's so dumb. It is actually such a dumb thing. It is the worst thing that's... Ugh. Whatever, man. At least the code looks clean for the developer, but not for the kernel. The code looks like this in the kernel. All of this for handling virtual memory. This entire 200 line of code mess of memory management just because they wanted virtual memory. Okay, so listen. Here's what we're going to do. We're going to simply allocate this memory does not actually need to sit in virtual memory. I don't give a shit, it turns out, about where it actually sits. Its address is going to be an ugly address. It's not going to be an address like this one, but genuinely, virtual memory is annoying to work with. I don't know what to do about that. Besides, you know, go back and not do that. No, state is the wrong thing to use, by the way. State is whether the process is running right now. What I wanted is the privilege level of it, which is just the SPSR. Is there a way to, like, decode it to know if the process is... Yeah, that's pretty much... Is privileged, I'm going to set it as a define is privileged SPSR, and it's going to be the SPSR and 0F. No, I didn't mean to do that. Yeah, if it's equal to 0, then it's not privileged. If it's equal to 1, then it's privileged. Okay, so that is correct. If it's privileged, the stack is only accessible to the kernel. memory. Otherwise, it is considered shared, accessible by both. Okay, what is your problem now? Incompatible pointers. Right. There's your U pointer. Ta, ta, ta. There you go. And now I'm going to give you a return sized pointer made up of the stack top and the process stack size. Where the stack is actually not being used for anything. Like I said, I'm not doing any special mapping here. I'm going to try to do just identity mapping. Okay, so take that, do a sized pointer. New stack for the process. And again, if I want to write this code properly with virtual memory, which, yeah, I probably wanted to, or whatever the fuck, then I'll just modify this function and the rest will stay the same. Alright. So now we have a fully set up thread. Damn it, I deleted half the code there that I shouldn't have. Now we have a fully set up thread with its own stack, empty registers. I'll handle that in a minute. Not really, not immediately, but yes. To know which process it belongs to, and an entry point, which is going to be whatever we tell it that it should. Okay, fuck virtual memory. This would have been a lot cleaner if it wasn't like that. Fuck's sake. Anyway. I forgot. It's been so long dealing with virtual memory that I forgot where I was actually working before. It's in syscall. It's literally right here, okay. Okay, so I'm going to register the signal handler for this process. And this is where it gets interesting. We're going to need to create the thread in here. So do a new thread for this process. Given the entry point, which is the handler, that's a function pointer, but really we're just going to take it as that. That is going to create a new thread, and now we have to modify signal handlers over here to be, instead of just the raw function pointer, a full-on thread. With all the implications that that has. Which apparently start with this if statement. Yes, it does actually. This if statement checks if there's already a thread valid for handling this signal. So if you already have a signal handler there, then you do that. Oh, well, you already have it, so you return false, I mean. Okay, otherwise we create the thread. We don't really need to check if the value that you passed as the signal handler is in the process's virtual address or not, because if it isn't, it will just crash the process, and that's their problem. I'm using Haskell and C. No, I've never used Haskell before. Alright. Then, in the scheduler, this here is where we handle the signals. Can signal be handled by a process? So this is essentially a queue of signals that have been sent to the process. When it's time to run this process, we check, does the process have a thread that can handle it? We don't immediately call it like that. Instead, we check, does it have a valid program counter? And if that's the case, we're going to do this. No. Wait. Yes. Okay, what does switch proc do? No. I want to do process restore. But I'm a little confused as to what the logic is to call in this here. Alright. Oh, this is in process restore. Okay, so no, I don't want to call process restore from here. Okay, so when we're supposed to run the current process, if the current process doesn't exist, we're trying to restore a null process, that's a kernel panic. Or if we don't know what process that is, that's a kernel panic. Or if the process has been stopped, if that's the case, we fully stop the process. And we just switch to the next one. Alright, I understand now why that was there. Okay, again, we check privilege level, which I'm just going to no is privileged. That's going to be the condition for this, which, by the way, I did put a parenthesis there. Okay. If the process is not privileged, we're going to do that. Otherwise, if there is a signal to handle, we're going to handle that signal. Otherwise, we're going to call restore context using the current process execution context or something like that, which is just going to be a pointer to this structure or this structure. They look exactly the same. That's the point of these two looking exactly the same. That's why I did it like that. But of course, I'm going to have to set the cpec to the address of the handler. Why am I pressing the wrong buttons everywhere? Okay. So there, we're going to restore the process. Not here, but here. They look the same, so the function should work the same way. Restore all the registers, restore the stack pointer, restore the program counter, and restore the status. But using the threads information instead of the other thing. And just to be safe, super safe, extra safe, we're going to copy the process's current... Again, I forgot what SPSR stands for. It makes it hard to actually talk about it. The Society of Pharmaceutical Sciences and Research. The current program status register. The saved program status register. Okay, so the program status register, essentially, we're going to keep it up to date with the one of the main thread. Just to be sure. Okay. And this is an assembly function, which here we have just defined as external, which is going to do the context switching and then put the execution in the program, so there's no need for us to return. This function will already return. Will that work? If so, the signal handler should work, but I'm gonna be fairly shocked if it works, because then virtual memory was easy to deal with? That sounds like bullshit. And there you have it. There you have it. Process has crashed. Permission fault third level when trying to access this value, which looks like the stack pointer I was talking about. Trying to execute a function over here. No. Hold on. There's something a little weird. Okay, maybe. It crashed at this address, which is the first address of the signal handler. Same. My signal handler was already there, so it's not going to show up here. Where is it? On quit. It's a call to print. Also, it doesn't receive this. I'll need to handle that. But the address that's crashing is actually this one. What is that address? I feel like it's probably its stack, but I notice here it says the stack pointer where it crashed is this one, which very much looks like the stack pointer for... it's the stack pointer for the process because we're retrieving that from that value, not the stack pointer as it was. Okay, yes, I think this is the stack. I think this here is the stack of the program that it was trying to run. Yeah, this is the address that it tries to access. This is the physical address of it, points to 0, 0. But the process is not able to access it because I haven't given it access to that, I believe. So I need to map it. Again, I figured it was going to be a permission issue. The code itself is kind of straightforward. It's just the stack itself that's kind of difficult. But just to be sure, new stack at llx stack limit. Oh, I may actually be giving it the wrong address space. New stack at this address. Yeah, that's completely wrong. Okay. Okay, so the problem is actually not what I thought. The problem is essentially that this address returned by this thing for the new stack is this thing here that starts with FFFF8. That maps to the kernel's permission table. And obviously the process is trying to access kernel memory that's a little fucky, so it doesn't let it do that. What if instead of doing this, I just copy the original stack pointer, like 7ff. Come on. Where is that? Can't find it, fuck's sake. Here. Okay, this is the address that the current stack sits at, which is like near the limit. If any of these zeros had a value, then when it's trying to resolve that address, it's going to go to the kernel and to the kernel's permission space. And it's going to be like, hey, this userland process is trying to access kernel memory, which is exactly what's happening here. So it crashes. But what if I instead of giving it this, I hardcode one of these values, but I change it to use 8. Suddenly it works. Okay. That's very good. No. Why did I think that worked? It didn't work. Process has crashed. Translation fault 0th level. Jesus. That's an entirely wrong level. Okay, so I'm not doing this properly. Oh shit. I feel like there's something really wrong going on here. In the that function that I added here, restore context, that is this function. Does it... I don't have an assembly. Okay, I hope this assembly language server is able to do something useful. Nah, I don't want to install it. Just gonna stop installing stupid shit. Anyway, okay, so this is the function that actually does the restoration, right? Restores the program, like that's the pointer to the thread. These are the registers. This is the SPSR. This is the stack pointer. And this is the next instruction to execute. Okay, so it actually does not handle virtual memory. That is interesting. Alright, so I'm going to do something stupid. So what I'm not understanding is, am I just not mapping this to the correct memory, which I think I'm doing here, but I'm not sure? Or am I... No, that's actually not it. The address that's crashing is this one. 9000007FEFE0. What address is that? Oh, it's the top of this once it goes. Okay. So it's the top of the stack. Yeah. Okay, so two things could be happening right now that's causing this to crash. Either I'm not telling the process, hey, I gave you this address to use as another stack, or I'm not restoring the process's address space correctly. But yes, that address that is crashing is within the stack. FEFE is near the top of the stack. Okay, how do I know? Because this feels like I'm adding a new address. Very much feels that way. Well, but to know that, I'm going to put the stack of this new thread in the same place as the stack of the old one. Obviously, this is stupid as hell. It's going to cause the program to crash in new and creative ways, but it's going to be different. No. It still fails to load at the 0th level with this address. That is not good. Did it just... No, that didn't copy. Okay, that's what's happened. Okay. So it should going a little bit too far. Oh, I see. I am actually giving it an address that it shouldn't have accessed. Okay, that's better. Permission fault third level. It crashed at this address. That's still not very good. But at least I think I did it right. I was given it this address instead of this address, essentially. That's the issue. Okay, so now is the crash that I'm getting still a permission fault? So that is not super reassuring to me. But at the same time, I'm doing some fucky stuff by giving you the exact same address. So let me give you a different one and see if that works. Crazy to see someone coding without AI. You know, it's sad that that's true. Ignore the crash. We're just gonna pretend that didn't happen. Okay, yeah, so this address is still crashing. Although, okay, translation faults 0th level again. So I'm just not mapping it correctly. That's the thing. That's literally all that's happening. It's fine. It's fine. Okay, that's fine. 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 Cool, 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 cool. Not a problem. Not a problem. Not a problem. I think. I just don't understand if the add virtual memory address is not adding a virtual memory address, then what does? That's all virtual memory's fault, bro. Now, another thing that I'm surprised by is that it's not trying to handle a page fault. Or maybe it is. Alright, so let me see. Trying to handle a page fault, right? We're trying to access a specific section of memory, and it doesn't work. It doesn't do what I want it to do. What can I do about that? Doing some access flags and stuff, finding a VMA, and if that fails, then you don't own that memory. But I'm giving you that memory. That's what this entire thing is doing. I'm trying to give you the memory using this address start, this address end. Oh, am I doing the end correctly? Protection level, kind of memory, and flags. Okay, so question number 1 is, am I doing this correctly? Stack limit, stack top. This is the new stack, yes. No, I'm again doing it backwards. Zeroth level still. My god. I just flipped 2 addresses around and absolutely nothing changed. How is that possible? Okay, but that changed. Physical address 00 status 1. Okay, try as it was before. What did that say? I could just read the logs, but I'm too lazy to do that. Same thing. Same thing. So am I not giving you that address? Okay, I still think this is the correct way to do it. This is what's adding the address. Okay, so we take the address. Zero these bits. zero out these bits of the exit, of the end. If the start is bigger than the end, return false. Okay, so that's why it was failing the first time. Probably because the start was bigger than the end. Okay, the other reason it could be failing is VMA count bigger than the maximum number of VMAs, which is Video Music Awards? I don't know. Virtual memory addresses. I'm just trying to find out. It's 128. Okay, so I don't think that's it. It can also fail here if ints is bigger than 0 and the start is smaller than the VMA's ints minus 1 dot end. This is incomprehensible to me. Oh my god. Who was it again that did virtual memory? We're doing this thing again. Who's to blame for this bullshit? The University of Manchester. The Atlas computer at the University of Manchester. For the love of God. They're responsible for like most of the issues I've had with this operating system. I swear to God. That's so annoying. No, I haven't used AI. It's strictly anti-AI project. Thank God. It mostly works, except for this fuck-ass thing. I wouldn't be surprised if they use like a super old version of Claude to come up with such a bullshit system. Again, the idea of it makes sense. It's just such a stupid system. It's such a pain in the ass for kernel developers to deal with virtual memory. It's like, we're using fake addresses, essentially. That's really annoying. And I genuinely don't understand what this is. Like, why are we doing this? Will this work? I don't know what I'm commenting out. No, nothing changes. No matter, I could comment out the entire kernel and the exact same problem will continue happening. Virtual memory really is the scourge of computing. Well, no, that's JavaScript. Well, no, that's Microsoft. It's actually shared amongst a lot of candidates. Mind you, none of this is actually related to multithreading. I'm just trying to allocate some memory. That's it. Alright. Let me look at something. What do we do when we allocate new memory? When we call a page allocation, we allocate with mmap. So that's different. Mmap is adding the virtual address in the exact same way. Anon demand user alloc 0. Okay, so I'm genuinely confused. Is it okay if I mean, this pull request added a lot of really good things and mostly fixed virtual memory, but it made it so incomprehensibly difficult. Yeah, okay, I'm starting to understand what the problem is. That seems to have worked. I mean, did I comment out the code that actually handles it, or what? Does this never run? That's the handler. Signal handler added. New stack. This never ran, but at least it doesn't crash anymore. Okay, but what I think is happening that was causing the crash is probably the kind of memory being stack was probably associated with some special type of permission. The problem is, go and figure where that is. When I allocate it as anonymous memory, yeah. Can I simplify this memory management in any way? I'm not entirely sure. But anyway, when I mark it as anonymous memory instead of stack memory, then it allows me to allocate wherever I want. Whereas I think when it comes to stack memory, it forces me to put it in specific places. Well, no. It handles it in specific ways. Okay, so I think the crash more so came from here than the actual allocating function. But yeah, that means I'll need to refactor this thing to be able to handle multiple stacks for the process. If you know exactly what to ask AI, it should give you the exact results you're looking for, so why not give you a try? Because that's not true. But let's put it this way. Give me the prompt, and I'll ask it. I'll copy it and paste it. I'm not willing to pay for any subscription, but let's do that. Give me the prompt that I'm supposed to run, that's going to give me exactly the result that I want, and I'm going to run it. Okay, so this time it created the stack correctly, it accessed the stack correctly, but no print was printed. And I wonder if that has to do not so much with the print, not so much with this, but with the print. So if I try to do a print L, which is the direct syscall, maybe that will work? No. It crashes though. Okay, hold on. Okay. It didn't catch it like it should have caught it, but it worked. It ran the function, but this didn't work. This didn't print anything. This probably did what it was supposed to do, then returned. The return doesn't really matter because it got to the end of the function and then it jumped to 0 because there's nothing at the end of this function. Normally this would be caught as the process exiting, not as the process crashing, but for some reason it got caught as the process crashing, but it technically worked, although it says with code 32, but I think that's just because of this crash. So I thought the weird thing is still it's not printing anything. Even though I thought maybe it had to do with the fact that this actually does use some memory that maybe it doesn't have available to it. But that's not really the case. Because I'm calling a syscall here. Although Oh. 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 Okay. When I call the syscall, this is getting worse and worse and worse. When I call this syscall, it does another context switch. When it does that context switch, it stores all the information of this thread on the main thread's information, not on this one's. So I'm going to need to fix that as well, which is very fun. That's very enjoyable. What if I don't call the syscall? What happens there? It still crashes like normal. Alright, there's an ad running, so I'll be back in 3 minutes. And I'm not sure how to handle this, but I'll see. Standing by what's gonna happen. I'm genuinely terrified to tell you, honestly. Alright, I'm back. Here's the thing. For anyone, there was someone in YouTube chat, by the way, who said, like, I'm copying you and starting my own operating system. Do multi-threading as quickly as possible, please. It's not difficult, necessarily. I'm understanding everything that's going wrong. Kind of. I don't understand the exact detail of what's causing this specific crash, but I understand the overall logic of what's happening. I understand the shortcomings of my system. I know how to fix them. They're kind of normal, kind of to be expected, but they're a pain in the fucking ass. Actually, the latest issue that I diagnosed as like the context of the thread is being put onto the CPU and then saved onto the main thread's space may actually be wrong. So that's good. And by may actually be wrong, I mean is definitely wrong. Yeah, pretty sure. pretty sure. That's good news, actually. I guess. So yeah, thread is running? I don't know. I don't know what's happening. I mean, okay. So this new thread has a new stack. When it had that new stack, it was crashing the second it tried to access it. Literally here. Not even here. Literally here. Because at the beginning of each function, C tries to allocate some space for the stack. And of course that accesses the stack, and that was causing it to crash. Which means we were getting to this point. But now the syscall is never getting called. Not returned from or anything like that. It doesn't look like we're in any way getting there. Doesn't seem like this is being called at all. Let alone returning from it safely. Now, it's not like I prepared a way to return from it safely. And if I did, you know, once you reach the end of the thread, it should quit the thread, not the entire program. That is behavior that I definitely have not programmed in yet. Quit the thread instead of the program once you reach the end. So that means there's a chance that it's causing the entire program to close, but not to crash. And most importantly, it should do that after telling us this. And also, on quit is literally a signal that gets sent when your program is supposed to quit. So it might seem like desirable behavior, but it wouldn't be. But either way, it's not working. Okay. What can I do to know exactly what is happening? First off, print L is a syscall. And it literally just does this. So either this is crashing, or the error happens some other time. That never gets printed, so the error happens some other time. Okay. Then another really weird thing is it says here translation fault second level, process has crashed with an address, an instruction of 0 and an address of 0, and then it says null pointer accessed at 0 because it doesn't detect that this is a... Alright, stop telling me to use AI. Like... Genuinely, shut up. I don't know what else to tell you, man. Don't know what made people in YouTube chat today decide that today's the day that we tell this guy to use AI, but like, I've already made it clear I don't do that. Your skill issues are not my problem. I can do this without AI. Thank you very much. I don't need AI. Alright, I'm kind of not seeing the handler that I was expecting to see here. Which is that if the process... Well, no, it's probably happening before that. Alright, ELR is here. No, it's kind of not here anymore. thing is, technically, if the ELR is 0, I'm not sure if I want to add this behavior back in, but it used to be there. If ELR is 0, then your process tried to execute an instruction located at address 0, which means invalid instruction, which means it's, well, no, it doesn't mean anything, but it does often happen when a function, like a main function, quits. When you get to the return from main function, it goes to address 0. But I think now there's some behavior to prevent that from happening explicitly. But that behavior is not in threads, so it still happens in a thread. But yeah, I'm just going to set it up here. Did a thread just exit? But again, I'm a little suspicious of the fact that I'm not seeing I'm a little suspicious of the fact that I'm not seeing the print at all. If I was seeing the print and then I was seeing this crash, I would be like, okay, the program didn't really crash. The thread just exited. Did the thread just exit? Okay, so it just so it doesn't show as a crash. That doesn't really change anything. But again, I don't understand what's happening. Is this ever running? And there's one way to know. I think we have optimizations off entirely, so I should be able to do this. Just gotta check real quick. Yes, optimizations are off entirely, so I can do this. Otherwise, I could just mark it as volatile, still would work. Brief overview of the current state of the project, what kind of OS I'm building. Okay, so it's completely from scratch, and that very much feels like what I was expecting. Okay. So the thread is constantly executing this thing now, which means it never gets to the end, which means it never quits that way. So my theory is correct. I do think this code is executing. I just think this is not printing for some reason. And I don't understand why that is happening. I thought maybe the syscall itself, the way that it retrieves the string to print, that's the problem. That could be a very valid reason. But it's not what's happening, because I also hard-coded a different print and it doesn't work. Alright, but that gives me something. The process does not quit when the thread never quits. What happens if I do this? Last thing. Then I'll properly answer your question, because I got interrupted halfway through. Now, genuinely, what was that? No, wait, no, hold on. No, hold on. It works. It works. Okay. Okay. Okay, threading works. Threading works. Can you tell I'm surprised by this? Again, printing from the thread does not work. Maybe that's a thing that I'm okay with, but like I'm kind of not. I'll need to look into that. But okay, threading works. And again, that issue I mentioned, when we go into a thread, we take the context of the thread, we put it on the CPU, it runs, it exits for a syscall, it gets saved. I was saying it gets saved to the main thread. No, it doesn't. It gets saved to the latest place where it was taken from, which is itself. So it gets saved in the correct place. The main thread continues executing completely separate from it, and it continues executing completely separate from the main thread. Okay. Cool. Signals implemented. Thank you, everybody. Never gonna touch this again. No, okay. All right. So the operating system is completely from scratch. By the way, to anyone doing the same thing, do this as quickly as possible so you don't have to consider so many things at once. Because again, I have to fake the threads stack because it's away from the normal stack, so the system doesn't like that, right? So make sure you consider when there's something that you have one of, and eventually you will have multiples of, write it as if you had multiples of it. Stacks, threads, all of it. That is actually generally good advice that I wish I had followed when it comes to this thing. It runs on ARM systems only, and I'm just implementing multi-threading right now, although I'm doing it in a very limited manner. I want them to power two things: a file system in user space and the signals. So I just tested sigquit, which works, but printing doesn't. But that's a syscall. Maybe I wanna understand why it doesn't work. That's the thing. That's the thing that I need to understand. Why didn't that work? But itself, it does work. So that is nice. And also, just to see if I can do this properly, right? Did a thread just exit? That's the check that I want to run in here. Or eventually, maybe even prevent this from happening in the first place. The same way that it happens in the main. I think there's kind of a trampoline function, so that when you call main, it sets another function that calls main. It's kind of faked, but it makes it so that when main returns, you go to that function, which neatly closes your program as opposed to crashing it. So maybe I want to do the same thing for the threads. I'll look into that in a second, but if I just don't stop the process at all, I don't consider it to have crashed. Again, I think the thread exited. I'm good with that. That's not a problem. And I go back to my process. And I don't put a while true. I let the thread actually exit. Just without considering the process to have crashed. Okay, we get the sigquit. That's good. Although it seems to be trying to schedule it multiple times or something. Because it's crashing multiple times. But okay. Making progress, making progress. Still a lot of refactoring that needs to be done eventually, but we're mostly good. Alright, we have threading now, officially. But, yeah, the other thing I need is that little trampoline function. I need to find it. If I'm not mistaken, that is in nowhere. It's a little suspicious. It should be in the process loader. Entry point. Should be setting it in X30. Maybe? X30 is the register where Is it called the link register? No, the return. It's called the link register, I think. Yes. When the main function exits, it returns to the previous function, which is the link register. But I'm not finding that behavior anymore, so I'm a little bit surprised by that. Well, that does beg the question of what happens if I just return 0 on main. Did a thread just exit? Hold on, let me not send the signal. I don't understand where the code that handles this properly is. I don't get it. Wait, I don't need this at all, actually. That's kind of weird. Yeah, somehow when I return from the main function, it is not considered to be a crash, and I don't understand where the code to handle that neatly is, because I need that code to also handle threads neatly. I would expect it to be somewhere here, but it never gets to process as crashed, which means it's the else of this. This is a kernel crash. This is a syscall. This is a page fault. I'm not seeing where that is handled. Unless, no, it's not handled by this either. I'm confused as hell. Where is that running? That is so confusing. But anyway, I'll find it eventually, I guess. Another thing I need to look at is this. Okay, no, actually what I needed to look at was this. Like I said, need to make sure that the main thread is being left alone when another thread is executing. The fact that this variable is there tells me that because I just modified that variable to point to the thread instead of to pointing to the other thing. Hello, Columbus. How am I productive during the heat? It's not that hot today, pretty much. There was a day in which I genuinely could not handle thinking. Surprisingly, today I've been doing a lot of resource-intensive work. It's been okay. Alright, one last... Okay, so I think we're good. I think we're good. I just don't understand. There's still two things that I don't understand about this whole threading thing. Number one, when the threading quits, the thread is considered... when the thread quits, when the thread gets to the end of its execution, that is considered to be a crash. When the main function does the same, that is not. I cannot understand which code handles that difference. And the second issue, print does not work from the thread. And while that is not necessarily a problem, well, it is a problem actually. What the fuck am I talking about? Am I not supposed to print inside of threads? It is a problem. The real question that I have is, what the fuck? Who is preventing that from happening? Where is that happening? There's no crash, there's nothing like that. I'm modifying a variable inside the thread, and that one gets actually picked up by the main thread. So I'm literally communicating with the main thread by setting should quit to true. I'm literally communicating with the main thread. And yet I'm not able to print this. This never prints. And this is directly a syscall. Print L. That's not the actual one that gets called. This is the kernel version of that. The real version of it is a syscall print L, which gets picked up by... Ah, that's maybe where I need to check. By this. Save, disable. Okay, so this is again storing the context of our thread in the thread itself. Disabling userland. Okay, I did think I disabled this. So yeah, just get rid of the call. Not disabling userland. We need it. We literally use it. Getting the current process. Getting the current instruction that's supposed to execute. The status of the process. Checking the exception level. If we're in kernel or user space. Checking the... what does this stand for? Exception symptom register. Essentially the reason why there was an exception in the system. And we're going to find out that that's because there was a syscall. We're going to check for that syscall. But it doesn't seem to be getting received at all. Alright. I'm going to try something. This cpec thing contains the pointer to which to restore and save the current execution context. Normally that points to the process, but now it actually points to that process's thread. So if this is not equal to the process, I'm going to put a panic in here. We're in a thread, because I want to make sure that this is being picked up. Although this needs to be cast to a pointer to be able to compare them. Okay, that already tells me something. AC at work doesn't work. I'm sorry to hear that. That absolutely sucks. I don't have AC, but it not working is actually worse than that. Okay, so two possibilities. Either we're crashing way before... Well, not crashing. It's not crashing. Everything works. I just don't understand. Why are we not getting to this point? This is a syscall. Oh, wait. I'm never sending the damn thing. Oh. Never mind. Okay, we're in a thread. Okay, there it is. Good, 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 good. Alright, so we're able to detect that situation with this condition here. I can use it to know what's up without spamming in all other cases. No, get rid of that. And we're going to check, not with a panic. Fuck it with a panic. Why the hell not? Let's panic a little bit. Maybe it's time we start panicking a little bit. Error code 3. That. Error code 3. I don't even have to look it up. That is a print. That is the print. Error code 3. Well, it's not an error. Syscall code 3. Why am I not seeing the print? Now it's because I added a panic before I get to the print. So that's my bad. The print. Okay, now I'm seeing that. I wasn't before. Now I'm seeing that. So that already tells me something. What is that something that it tells me? It tells me that this thing, which is a macro, is probably the one causing the process from not doing that. For instance, if no context argument... Okay, I see. Oh. 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 Okay, I understand what the problem is now. It is worrying-ish. The problem is, we're using the processes x0 to know what to print. The processes x0 is not what we should really be using. That's not the thread. And I'm gonna have to severely change a lot of these syscalls to handle this properly. This is the current thread that is executing. And if I just copy this, because expanding the macro is not a good idea. So I'm just gonna copy the macro and write its thing myself. Let's just get rid of all of this, actually. The value that we want to check is actually from the current thread proc x0. Yeah, I can keep this. This is a false according to this. And then that gets stored in here. This needs an explicit cast to thread. And this is that. A little bit of that. That should restore the print. And actually tells me what I can do to fix this. I'm told to quit. There it is. Okay. Essentially, I was getting x0 from the main thread, not from the I'm getting x0 from the main thread, not from the current thread. So In order to handle that, this, and this need to point to the current thread, not to the context. So do this, that's it actually. So do this and this. You know what, hold on. Before I start doing this, at the very least do a little stage. Line 13 at 49 context. No, I think that's okay. Thank you, though. If you mean this one, and this one, that is still the process's context, and it's needed for validate address. That's actually checking is the value that you're trying to use within your allowed values. You know, so in your process's memory. So you need the entire process's memory, not just this thread. The only thing that matters here is this one. Which, by the way, why am I accessing it 3 times? So weird. Because can I not just put it here? No, if no name. And then name. I'm already doing that here. I don't understand why I didn't do it in the other ones. I'm accessing the same register 3 times. That's kind of dumb. Name. Name. Okay. The problem is, all of these syscall handlers now need to have access to the current thread. From the thread T pointer that I'm gonna need to add to literally every single one of them. Like you. Alright, so a little bit of boilerplate incoming. How's everyone doing in the meantime? Again, if there's anyone working on operating systems, or actually, I believe that the way that I generalized this before probably makes it apply to a lot more types of projects. If there's gonna be something that you have multiples of eventually, but right now you only have one of them, then write your code as if you had multiples. So translated to what I just did with threads, so far the kernel has had only one thread per process. So all the code is written with one thread in mind. Now that I'm having to write code for multiple threads, I'm having to add all this extra code, I'm having to refactor all these extra things. If instead, I could still have had only one thread, but I had written the code with multiple threads in mind, from the very beginning, over months and months of work, as opposed to all at once, I would have been able to handle this more gracefully. And I am seeing that sometimes this is leaving errors behind, and that's very, very concerning. By the way, this is a syscall in case there's JavaScript detected. Just a little reminder. With that being said, this thing also needs to have that. Now what is your problem? Incompatible pointer passing what? Ah, okay, now I understand. This needs to be cast to a U pointer. Alright, that's not a problem. Get time, I must have skipped you. Sorry, my bad, my dude. There you go. And now, the current thread is taken from casting the current program execution context. Boom. And we no longer panic. Let's see. Is that gracefully handled? Well, I forgot about this part. Okay, so of the two problems that I mentioned, one of them is fixed. Weird indentation. Meh. One of them is fixed, which is all the arguments for syscalls were being taken directly from the main thread instead of from the current thread, so that was causing that issue. And one thing that I am glad about is that here there's always been get current process instead of just accessing the current process from here, because that would have crashed. Because there's values in a thread that aren't available in a process. Also, the getting arguments for a syscall from the main thread when it's actually being called from a side thread, I was gonna call it, from a background thread, is kind of weird that it didn't crash, but apparently it worked. It didn't crash or print garbage or anything. That's kind of surprising. Feels almost coincidental, but I'm not entirely sure. Okay. I still want to find out, how do I quit a thread properly? I remember there being some mention of... there it is. See, that's what I'm talking about. There it is. Ow. This is the kernel process return trampoline. This is the one that gracefully handles a kernel process quitting, but not a non-kernel process quitting. Who's handling that? I really want to find the code that does that. Oh my god. I just realized, literally, it was here. 0x30 is what I was looking for. I should have been looking up 30, which is the number of the register. I looked it up in hexadecimal. That's why I couldn't find it before. It's this shared base. What is that? What is that? When the main function exits, it goes to this shared base. I just don't know what it is. Shared pages, shared size, memory map top. Why are you doing that? Again, like I say, this code. I used to have like minimal code for handling virtual addresses. Now that I have proper code for handling virtual addresses, it is spaghetti. It is ridiculous. It is incomprehensible. It's not the code that's the problem, it's virtual addressing that's the problem here. I don't remember what the point of this thing... Oh, okay, here it is. No. No, this is not it. I still don't understand what this points to. I don't get it. There is a shared base. I don't know what it is. But when the main function quits, it returns to the shared base. I mean, I can print what it is. I'm not sure how helpful that's going to be unless it's a value that I recognize. But I might as well. Otherwise, what am I going to do? And I need to put in the default process. Just actually immediately quit. Screw it. Process ended, process ended. And there it is. Remember when I rewrote my kernel in C++ and then reverted it a few days later? Yep, that was a good choice. Is this address hard-coded anywhere to do something special or something? I am confused as to what's going on here. By the way, there's like an entire disassembler in here. Well, entire. It's very limited, but it's there. It's just not being used for anything. I'm probably gonna move it out of there, clean it up, and do something with it. Anyway, genuinely, what is going on? I don't understand my own code now. There is special no free memory that's being mapped as the shared base. I don't remember any of this. There's also nothing being done at all when it comes to special memory. There's no such thing as special memory besides this frame buffer and that shared memory. Okay, I understand what shared memory means now by looking at the code. It just means shared with the kernel. Just again, process has ended with code is from syscall halt. So who's calling you? This is what I'm so confused by. Oh, there it is. This is some weird shit happening. I don't like it at all. Oh, God. Well, no, I kind of get it. I kind of get it. But I don't like it. I'm probably gonna get rid of it, but at least I understand what's happening. Turns out, there is a section of memory that the kernel then points to, hard-coded to call halt on the current process. I understand why it's done this way. It's essentially the equivalent of the trampoline, but in a it's the equivalent of the trampoline, but with virtual memory, because that kernel trampoline that I just looked at, which does the same thing, stops the current process, that is handled by kernel memory, whereas this is in process memory, so it needs to be done like this. It's literally just a call to halt with a, yeah. It's literally just an instruction call to halt. That's just very weird, though. I'm going to need to severely refactor a lot of this code. Like, a lot of it. But when it comes to the process, is there anything that I should do? Like, the real issue that I have here is that if I do everything correctly, my thread here does whatever it wants and then it returns true. It's literally a signal handler. It's supposed to return. It's not supposed to run indefinitely or anything like that. What bothers me is that this gets called multiple times and I'm not entirely sure why. I think it's just because the program is kind of trying to run multiple times. Not that it's trying to run multiple times, but just like it doesn't do anything. Like it finds itself at instruction 0, so it just keeps trying to run instruction 0, and every time it crashes, and every time it does this, and there's no way to stop the thread from running. I think that's literally it. Because to be fair, threads don't have a way to be stopped in the same way that the process has a state. Here, the state. Which type def, move this whole thing out of here, put it here. All right. Ah, that's not it. That's not it at all. No. I mean, this kind of will be necessary, but it's not right now, so maybe I'm gonna keep this. But that's not the problem. This error, I still don't understand what it is, but that doesn't really matter. That's just Clang being Clang. Okay, the problem is that I'm being stupid here, essentially. After I exit the thread, I'm literally doing nothing instead of switching to the next one. That is literally the entire problem. Embedded use of undefined type enum process state in the scheduler. Okay, I need to rewrite some code here as well. Where is that? Line 375. There. How's that? There's C++. Wait. Why is my input code in C++? Should you? Should you? You should not be C++, should you? You fucking lied to me. You're pretending to be something you're not. See how C++ is so awful it sneaks itself into your code base for no reason? Why are you doing that? Because now I can just get rid of... What is happening? How did I do that? I have no idea how I made my cursor go to both of these. Let me see if I can do it again. Not like that. Select that. Do it like that? No. I don't know how I'm doing that. Well, how I did it the first time. So I haven't been able to do it since. But anyway, C++, get the fuck out of here. My dude. Embarrassing that I pretended. Okay. There we have it. Perfectly written code. Okay, threading is done. No more threading, nothing else is needed ever again. Obviously not. I just had a phishing email with a remote work and software engineer position. Temp job market so cooked, scammers stop paying Nigerian princesses starting becoming HR. Are we that cooked? I've actually heard of that. A lot of the times, especially to like get you to run some shady code, like supply chain attacks often happen like that. Just like target someone, make them do an interview. Hey, run this code. Boom. I've heard a few stories of that happening. But you know what's even sneakier than software engineering interview scammers? C++. Why was this class C++? That makes no sense. It is a genuinely inferior language in every way possible to C. Why was it there? Okay. I think I solved all the problems with threading, surprisingly. I think now we're officially good. Although, wait, maybe I can be even smarter than this. No, I can't. Yes, I can. No, I can't. Okay. I'm going to need a syscall to quit processes. I'm going to need a syscall to halt threads, not quit processes. I have one of those. But since I just introduced threads, I need a syscall to end a thread. And then, in the process loader here, I can just use the same thing here, this shared base, which I didn't understand what it was, now I do. It is literally one instruction which quits the process. If the main function returns, that instruction gets called, essentially returning the main process. And what's best is the main function returns a number, that number gets put into x0. When that instruction gets executed, it automatically forwards that instruction onto the syscall, so the exit code of the main function gets forwarded as the reason we're quitting the program. So that's cool and all, but I'm going to need to do a new syscall, which I'm going to introduce as 36. And that's going to be the halt thread. There's going to be another one eventually for start thread or something like that. But I don't need it right now. I only need the one to halt the thread so that I can put it here. All right, and I also want to save this somewhere in the process. So I can keep this address, and now when I create a new thread, it's going to be easier if I do it like this. T-regs30 equals to the process's shared page plus the size of a U32. Essentially, when you return, you're now going to be pointing to not the halt instruction, but the one after it, which is the quit thread instruction. No. Yeah, kernel processes don't have this. All right. This will only work in userland. It will not work in kernel mode. So I'll need to handle it separately. But that's a different story. Again, big refactor of the scheduler, big refactor of the process loading, big refactor of a lot of things. Most importantly, I want to standardize some of it, because there's a lot of repeated code between creating a kernel process and a normal process. That needs to go away. But anyway, new syscall. You can't create threads, but you can kill threads. It's going to be called halt thread with an exit code. Since halt is going to halt your entire program, but halt thread is only going to halt the current thread, unless it's the main one. If it's the main one, I'm going to ignore it. Or I'm going to use it as quit the whole program. I'm not sure. Probably that. Anyway, halt. Going to create the new one, and it's going to be halt thread code. not just halt thread. Code would make more sense. Code. Okay, and then I can implement this new syscall. As syscall halt thread. I'm going to put it right under this one. Clang! I need you to work. I need to be able to jump to shit. Come on. Thread. Ah, okay. There is one more thing I need to remember about the syscalls. Everywhere that I'm doing this, that's no longer valid. There's 38 instances of that. Okay, I'm about to end the stream anyway, so I'm gonna have to refactor a bunch of shit. I'll do it in a minute. Well, let me at least get started on that. I might even be able to just do this. I'm not sure. Anyway, to halt the current thread, right now, all it takes is to just switch the current process as a yield. Well, no. If the current thread is equal to the process, then you're going to stop the current process using the return type, that. Otherwise, you're going to yield. And we are just comparing addresses. Alright, so if we're in the current thread, we finish the entire execution of the program. If we're not in the current thread, we call this thing. So I will no longer be getting the thread trampoline issue here. I hope. Alright. Time to see if any of this has worked. No? Halt thread undeclared. That is correct. Because this is now halt thread code. Okay, process crashed, so that's not good. This did not get called. By trying to access that instruction address 4. So I did something wrong, actually. There's a lot of redundant code here. Like, this will never happen, my brother. That's weird. The shared base and the shared page are separate. Oh. The shared page is literally shared with all the processes. So this was incorrect. It should go to this. USB complicated on the Pi 3. Not really. It's simpler than the other one, but it helped that I already had a lot of code for USB. Okay, signal handler. I'm told to quit. Process has ended. That's not good. Wait, am I literally printing process has ended? Where instead I mean... Yeah. Thread has ended. So I already had a lot of code for XHCI, which is the 4B and 5B. Okay, thread has ended. Then the execution of the main program continues. Then it receives the quit, or it notices the quit, and it quits. Very good. Very good. We are handling that properly. Just to do a little bit more testing. So yeah, that really helped me when it came to that. Already having some code, but even then it was simpler than the other one. You just have to understand how DWC2 works. Okay, very good. And now, if I run halt thread from the main thread, will I halt the entire application? Did I even do that? No, I didn't. Okay, stop process with code -1. That's very good. Okay, so it does quit the entire application. Alright, there is a severe amount of bullshit that comes with virtual memory. And it's a lot of stuff for me to sort through. A lot of boilerplate that I still have left to write, but threading is kind of implemented. Kind of. Alright, but that's definitely enough for now. I want to quit while I'm ahead. I did everything I needed to do. Of course, I wanted this for the file system, but like the same thing that I just did here for this, I'm going to be able to do for the file system. That's okay with me. So I'll do that sometime this weekend, but I'm not sure if it's going to be tomorrow or Sunday that I continue doing operating system. For two reasons. Number one, it's time to make a Lisp interpreter, which actually relates to the operating system because it's going to be my scripting language for the terminal. It's going to be the best terminal ever, trust. And reason number two, it might take me a bit to refactor all this code. There's some stuff like just moving some stuff from one file to another. There's some other that's like, I need to understand the logic of why this is happening and handle that properly. Being able to handle multiple stacks, for example, in the allocator for the stacks. Being able to handle any limitations that might come with that. Something simpler, like for example, the returning from a thread in kernel space. Much simpler to do. But yeah, I'll have to handle those. And that is going to happen off stream. After which I will be able to start doing file system and user space stuff, and that's where the fun truly begins. That might be tomorrow, that might be Sunday. I guess we'll see. It depends on how well I'm able to, first off, test that everything I do continues to work. Second, refactor what I need to refactor. And third, anything else that I need to handle, I guess. Alright, but that is going to be it for today. I'm going to have a lot of copying and pasting and checking and running and cleaning and so on. So, again, maybe tomorrow I'm going to continue working on this. Maybe I'm going to do terminal, well, Lisp interpreter stuff. I guess we'll see tomorrow. Thank you so much. I'll see you then.